Hello everyone, I would like to thank you all for coming today, and today I'm going to be talking about using speed bumps as a source of clean energy. Moving forward, as humans, we try to reduce our carbon footprint, and this is my contribution to that. As you can see behind me, residential and commercial, industry, transportation, and agriculture are the highest produce the highest carbon footprints. And as we know, higher amounts of carbon footprints cause the phenomenon known as the greenhouse effect. In short, the greenhouse effect traps the heat from our sun into our atmosphere with the carbon dioxide inside our atmosphere. Now, there has been an improvement to combat this. The improvement can be seen through companies such as Tesla, LI Auto, and Lotus Motors on the rise as making electric vehicles. Now, this is not only a car company problem anymore, as even countries are stepping in. This can be seen through the actions of the EU, is banning the sales of gasoline-powered cars by the year 2035. But why should we stop at cars? So I started looking around. I started looking into our cities. I saw that there are many contributions there, so I started looking elsewhere. I started looking at our roads. And in my opinion, something that we can use are speed bumps. Now, why speed bumps? Speed bumps, they have an arc shape, and in my opinion, we can use this arc shape to our benefit. Now, the design, I had first one concept. I first thought of one long cylinder block running across through a whole speed bump. But this will cause stability problems, and also, not only that, it will cause problems for the driver, as one side goes down before the other, and causing problems for the car and the driver, and also causing efficiency problems as we're trying to maximize efficiency. And there are three mechanisms we can use to achieve this. The first mechanism was hydraulics, using water as a source of energy. The second was mechanical, using gears, and the third was gas. I ended up choosing hydraulics. But why hydraulics? They're easier to manage generally than gears. So let's say if something breaks, we don't have to take the whole thing apart and check out which gear has caused the problem. Also, they are very much more efficient than gears, as moving parts will cause a lot of friction, making us lose a lot of potential energy. Now, it leaves us between gases and hydraulics. I ended up choosing hydraulics because of that. Hydraulics are more reliable, hydraulics are less likely to combust. They're easier to manage under high amounts of pressure, which this will cause, as the average car weighs around 1,305 kg. And putting all that pressure onto a gas can cause problems. Now, using and storing the energy. We answered the question of how, now we need to answer the question of where. To use and store it, we need to use something that we can store it in. We can use a battery, but not just any battery. We have to use something that we can recharge. And recharging, we can't use something like an alkaline battery, as those are one-time use. We have to use something such as lithium ion, the same type of batteries that you can be found in electric vehicles. Now, where it can be used, some research has already been done on this, and they found that on average, if 2 to 3 cars pass over the speed bump in a minute, they can produce over 2.9 kilowatts per hour. Now, this may seem minuscule, but relatively, it is very high amount. As the average light posts use 30 watts of energy per hour. So, putting in that into account, we can use one light post for up to 30 hours. Just easily. But even if the government decides that it can be also used for residential and commercial uses, this can benefit the residents as well. Let's say the average computer, it uses 300 to 600 watts. So 2,900 watts of energy. That means we can use our computers for around 6 to 8 hours. Now, this is the design where this is the design where I mocked up. I know it's not the best, but here we are. When the car goes over the speed bump goes down. It's spinning the turbine. This spinning turbine generates energy. It works as the same way as dams do by generating energy. When high amounts of pressure go onto a turbine, this spins the turbine, generating amounts of energy. It goes into the battery or the traffic light, where it can be stored and used. Now, there are still some problems that need to be addressed. These problems are cost effectiveness. Now, we need specialized people to dig up the ground and place these problems. And we can't, even if we count in minimum wage, which it isn't, because we need plumbers, electricians, and other sorts of degrees, and degrees cost money. And these problems these values will add up, causing problems for us. And there's another problem of efficiency. How much energy are we getting back in return? And the average kilowatt is 18 cents. So per hour, we're generating around 68 cents of energy. Now, there's also a problem of maintenance. Unlike a normal speed bump where you can just replace it easily, this one you'll have to dig it up and check what the problem is. It can be an electrical problem, or it can be even a water system problem. And these causes can add up as well, reducing the efficiency as well. Now, even with all of these problems, I hope that this project is possible, hoping and leading to a greener future.